Technology Hour. I'm Lynn, your host, and today I've asked Owen Fonorow, the director of the Vitamin C Foundation, to come back and share with us some more information on a vitamin that we all know we need to take, vitamin C and ascorbic acid. It's very vital, in fact, essential for human beings, yet we don't store it too well, and we need it on an hourly basis. So welcome to the show, Owen. I'm happy to have you back, and there's so much about this topic, and we're going to be talking about heart technology, lysine, and vitamin C right off.
Well, thank you. Yes, it's great to be back again, and thanks for inviting me. Can you hear me?
Yes.
Okay. Yeah, I don't want to repeat what we spoke about before too much, but we probably should review just the basic idea that there is a complete unified theory that has been developed from work that started in the early 50s into a theory that what we call human cardiovascular disease should really be called chronic scurvy, which means non-acute scurvy. And as the human body does not get the amount of vitamin C that the animals get, the arteries tend to weaken, and what happens, what could be almost considered a healing process, as plaster-like casts form on the arteries, protecting them from leaking.
Like a patch for the inside of your inner tube on a bicycle or something.
Exactly. And what's interesting, and what we mentioned last week, is there's two cornerstones to this theory. One being that the animals, which make vitamin C in their bodies in very, very large amounts, between 6,000 to 13,000 when adjusted for body weight on a daily basis, do not get this kind of buildup, the plaque, the patch. They don't seem to need it.
And that plaque we disclosed, we shared with the audience is actually, there's a name for it. And is that
the lipoprotein small a? Is that what we're...
Lipoprotein small a, which is naturally occurring, and it actually should be a friend, not a foe.
You know, that's right. That's the theory that in human beings and the very few species that haven't produced their own vitamin C, that this is really a form of cholesterol, has evolved as a surrogate for low vitamin C. And what's interesting, and what Pauling first brought to my attention, was that the animals that make their own vitamin C don't have this particular lipoprotein in their blood. It's the animals that don't make the vitamin C, and there's very few of us.
That make this lipo small a protein.
That's right.
That is there to patch a potentially leaking artery.
That's exactly right.
So there should be a shut-off valve that says, okay, I've got enough here, I'm going to stop producing that. And of course, that's when we should be supplied with some more vitamin C.
That seems to be the direction that the research is taking us into that area. What Pauling and Rath did, I mean, the first experiments were done in the early 50s that showed that vitamin C could basically prevent atherosclerosis in the guinea pig, which does not make its own vitamin C. And then they went off into humans. But they didn't know about lipoprotein small a in 1953. It looks like, from looking at the patents that Pauling and Rath have, that the first people to identify lipoprotein small a were in the 1960s, although not much of the work was done. And then in about late 1980s is when they discovered that it was lipoprotein A that binds to the lysine binding site and as you said, sticks and forms the patch.
And of course, lysine is a major cornerstone to our collagen matrix, which makes up all the ligaments and arteries and our human flesh.
Absolutely. And what the theory is, just to get right to it, is that when the artery does what they call a lesion, but it could be a crack or a sore, the collagen that's wrapped around our arteries, providing a girder-like structure, pieces of the lysine that do make up that collagen start to stick up, and that's what attracts the lipoprotein small a to start forming the plaque. It's called the lysine binding site. There wasn't a Nobel Prize necessarily for this finding, but it was the finding that led to the idea of the lysine binding sites that Pauling mentions in the video on all this. Mm-hmm. And so what happens is, knowing that these molecules stick to these lysine, the pieces of the collagen, as you mentioned, the structure of the collagen that sticks out during an injury.
You can kind of see it as hair that is like a strand of hair that is what we call a split end, where the actual hornus layer is beginning to curl up.
That's right.
And this comes along and attaches to it because it's going to smooth it down.
Right. And what Pauling said, and this was the invention. So what the Vitamin C Foundation, what's been known since the 1950s is that a deficiency in humans of vitamin C leads to the problem, but to reverse it requires the amino acid lysine, which, like vitamin C, there is no known toxic dose. In other words, you can give any amount to animals. They talk about, the lethal dose level, LDL 50, that kills half the animals. Mm-hmm. You cannot kill an animal with either vitamin C or lysine. So you have two completely non-toxic substances, one which is basically at the heart of the problem, the other one, which one of our our premier chemist says that any physical chemist would tell you, that knowing about the way that this builds up, that increasing the concentration of lysine in the blood will tend to dissolve atherosclerotic plaques, and that was his major contribution to this.
And both vitamin C and lysine are essential, means that we don't biologically transmutate it when we don't have it somewhere to grab.
That's right.
That we have to get it from a diet.
That's exactly correct. In fact, I may have this number wrong, but I think you have to get at least 2 grams a day to survive. So in other words, to stay in nitrogen balance. So you have to get lysine every day, just like vitamin C. Mm-hmm. So that's the basic idea here, that there is a mechanism. Once I started the research, trying to follow this through back in history and forward and see what's going on for people, whether people are looking at this and investigating this. Pauling's associate in this, whose name rests right next to Pauling and every one of the patents and all the papers, is Matthias Rath. And Matthias Rath also recommends the amino acid proline. And so this was not specifically recommended by Pauling. We looked into it, and actually after Pauling died, they did discover the proline binding site. I've talked to the people at the University of Chicago. And in fact, this binding site also seems to be what holds the sticky, it's called ApoA, surface to the LDL, or bad cholesterol molecule, making lipoprotein small a. So proline seems to be involved in both putting the molecule together as well as sticking. And in the test tube, proline is at least 3 times more effective than lysine in dissolving plaques.
All right, we're going to be right back, so stay tuned with us. We're going to have a great show today.